Okay, good morning and welcome back. Hope everyone had a good weekend. So we're almost, or we're starting the last, I guess, the last third of the course. And so most of you, or a lot of you have already submitted your midterm two, which is due today. So if you haven't done that, you have till the end of today to submit your midterm two. And it looks like, more than half the students have already done that. So let me know if you have any questions, but just make sure you get midterm two emailed to me sometime today if you haven't done so already. And then I think I finished or I graded all the rest of your assignments. And so you should see grades for this assignments up to example 14.1. Including the extra credit. And so double check that you confirm your grade for those. And you should see grades for those. My solutions are also posted for all the assignments up to example 14.1, including the extra credit. So all the assignments you see here, you should have grades for those. And yeah, so we're about to start the final third of the course. So we're basically gonna spend some more time on chapter 14, and then spend the rest of the time on chapter 10. And I think I'll have a couple more extra credit opportunities coming up, and so there should be a few more of those. But let me know if you have any questions on your assignment grades or anything like that. But today we're going to do examples 14.2, 14.3, and 14.4. So there's three of them, but they're all relatively short. So we should have plenty of time to do these three for today. So let's go ahead and you can open up the Word document, for example, 14.2, 14.3, and 14.4. And then the first one we'll need, you can open up the cost regression number one. Okay, so we're going to do some multiple regression today. And so we're going to use more than one variable that affects the y variable. And we're also going to introduce binary or dummy variables. And so these are the kind of the new things if you've taken like statistics or econometrics or any kind of regression analysis, you might be familiar with some of these concepts. But if not, we'll just cover the basics. So there's a couple of videos. I think they're both like 20 minutes, so maybe a little bit longer than normal. But if you have time, and if you want some more clarification on these two concepts, I'd recommend these two videos here. Let me set up example 14.2 in the older version. It's this one. It's chapter 16 in the older version, but I think it's the same thing. So estimating total cost for, wait. Yeah. So estimating total cost for a single product. So for each of the past, consider a company that produces a single product. For each of the past 16 months, the company has kept track of the number of units produced, as well as the total cost. Okay, so the data appear here as well as in the spreadsheet. What can simple regression tell us about the relationship between the two variables, and how can it be used to predict future costs? So we're going to start with one variable, and then we're going to add some different types of multiple variables. So first, we're just looking at, we got 16 months, and we got, this is how many products or how many units, like the quantity each produced for the single good. And this was the total cost for each of those months. So, in month 10, the company produced 200 units, and the total cost was $60,000. Okay, so let's use this relationship to estimate a linear behavior between total cost and units produced. And then once we understand the single product example, we'll move on to multiple products in the next two examples. All right, so let's start with example 14.2, and again, open up the cost regression one. All right, which is this one. You see the months, and you see the units produced, and you see the total cost. All right, so we've done this before, and let's do it again. Let's just make a scatter plot. Of units produced versus total cost. All right, that's step one. Okay, so we're here, we see here's units produced. Oops. Here's units produced, and here's total cost. So you can go ahead and select all of the B and the C column like this. So just select this area, which is B1 to C17. So all the actual units produced with the corresponding total cost. Now, we don't need the next 2 months because we don't have data on that. We just want to see what the actual data looks like on a scatter plot. So select B1 to C17 and then Insert tab. And you should see an option here for Insert Scatter. So let's do that. There you go. So you just want this one. Scatter plot, so just the regular scatter. We've done this before. So scatter plot with insert charts and then choose the scatter plot, and you get the scatter plot of units produced and total cost. Okay, so let's make a couple labels of the axes so we can see what this is, and we'll move on to the next step. But just click on the chart and click on the plus sign for chart elements. And if you're using a Mac, you got to do that. You got to use the drop-down menu and get the chart elements. But I think we know how to do that now. So chart elements or the plus sign, and let's click on axes titles, and let's unclick the chart title. All right, so the y-axis is total cost. Okay, and the x-axis is units produced. All right, so we got that, and then I think we can go to step 2. All right, so you can clearly see that there's a positive relationship between units produced and total cost, which makes sense. The more units we produce, the more it costs us. All right, so we've done this a few times. Let's add a linear tread line. All right, and then let's display the equation on the chart. Let's also display this r squared value on the chart. I'll explain what that is if you haven't seen that before. All right, and then we'll just format it to number with 2 decimals. So let's go back to the spreadsheet. Okay, and so you got to get the chart elements or click the plus sign. All right, and then go to where it says trend line and click on the little arrow and then click on more options. Okay, and you can leave the linear one, but you want to click 2 options down here. All right, so click both those things at the bottom, the box that says display equation on chart. You can click that. And the one that says display r squared value, click on that too. So those 2 options, you should see that on your chart, you've got the trend line, the dotted line, the equation, and then the r squared value. Okay, and then the final step here, or the final part of step 2, is just to format the trend line. So you can click on the trend line equation and right click it. And then where it says format trend line label, click on that. And then change the category to number. And then you can leave it as 2 decimals if it doesn't have that, and then leave this with the comma separator. So number with 2 decimals in the comma. So it should look like this.
Sorry, Professor, could you please do it again?
Yes, I can. Let's see. Do the which part? The trend line or just the formatting? All right. So I'll do the whole step, the whole process again. Not sure where we left off. So let's so we got the scatter plot. So we got the labels. This is total cost, and this is units produced. So now let's do the whole trend line part, the whole step 2. Okay, so click on the chart and then click on the plus sign or go to chart elements. And then you want to go down to trend line and hit the arrow. And then you want to go to more options. Okay, so the default is linear. You can leave that. And then the 2 things you want to check here are display equation on chart. That's the first thing. And then the second thing is display r squared value on chart. So you should see the equation and the r squared value, which I'll explain in a little bit. Okay, and then we just wanted to format it to look more readable. And so to do that, you can click on the equation box, right click it, and go to Format Trendline Label. And here, under little options, just change the category to number, and the default, which we want, is 2 decimals if you need to do that, and then leave this box checked. So you got number, 2 decimals with the comma sign separator, so it should look similar to my display box here.
Yeah, got it. Thank you a lot.
Okay, you're welcome. Okay, where are we? All right, so we did step 2. Now let's do step 3. Actually, first let me just comment on the r squared. So the equation you've seen before a bunch of times, but this is new, the r squared. All right, so this sounds, this is the definition, or I think this is how I describe it. So the r squared value, that's 0.97. The definition of this term, if you haven't heard this in statistics or some kind of regression analysis course, this is just the percent of the explained variation in the independent variable. That should be the dependent variable. Okay, so the dependent variable is the y variable, or usually the y-axis. And so in this case, that's total cost. Okay, and so what the r squared value tells you is on a scale of 0 to 1. How much when the y variable moves around, in this case, it's total cost, how much of that is explained by the given equation, this equation. So if it's 0, then nothing's explained. If it's 1, then 100%. You nailed it exactly. So we have a pretty high value of 0.97. And so the way you'd interpret that is like this. All right, so I said it was the percent of the explained variation, and so that's exactly how you interpret it. So the 0.97 on a scale of 0 to 1, 0 being nothing and 1 being 100%, we get 97%. So 97% at the variation of total cost is explained by this equation, and that means that when you get new observations of total cost, that this estimation explains about 97% of it. So that's pretty good. And you can see that the observations are pretty close to the line, the dotted line. And so the closer they are, the better it's going to explain it. So this is always how you interpret the R squared for some equation. It's how much of the Y variable is explained by the given estimation. So the Y variable is going to change, but the interpretation is the same. Okay, so step 3. All right, so we've done this before. Let's create a new range in column D called estimated TC for estimated total cost. And then let's calculate the estimated total cost for each month. And then we'll just drag that, we'll just apply it for 2 more months. And for the single good, that'll be our prediction. And then we'll extend this concept to more than one X variable in the next 2 examples. So to finish this, let's go back to the spreadsheet. I just moved the scatter plot over 1. And so in column D, let's call this title. Estimated TC for estimated total cost. And let's get the estimated total cost based on the equation we got in the trend line. So let's just type it in right here. And D2 equals all right, so we're typing in this equation. So equals 23,643.26 plus 198.47 times X. And X is all the units produced. So we're trying to see how units produced predicts total cost. So that's what we're doing. Equals, so just type in this equation. Equals 23643.26 plus, in parentheses, 198.47 and times B2. And so remember the last example that was actually on the midterm. You type in your equation and your X variable was the number of units or the time. Now here, we're looking at how units produced affects total cost. So the X variable is units produced, not the month, because that's what the graph shows. So how this affects this, therefore the X variable is units produced. So pay attention to what your X variable is on the X axis, and that's what's going to go into this, X1 or X variable thing. All right, so if you've got this estimated total cost in D2, you can apply it to the rest of the months, and all you have to do is grab the bottom right corner and drag it down like this. Okay, all the way to D19, and then while we got this selected, let's format it to look like the currency with the $sign. So to do that, Home tab, Format, and then Format Cells, and then you want to choose currency, and then it should give you the 2 decimals and the $sign, which is what you want. So when you formatted currency, 2 decimals, $sign. and you should get these values for your estimated total cost. So basically, this is the month. This is how much was produced. This is what the actual total cost was, and this is the prediction based on our trend line. And we want the trend line so we can extend it 2 periods. Because if we know in month 17 we're producing 400 units, then that's our estimated total cost. All right, and if we know in month 18 we're producing 800 units, then that's our estimated total cost. So double check, these are the two values that are important because these are our estimations for the next 2 months given the trend line that we estimated. So do we get these values here for D18 and D19? All right, so what we did here, we're pretty much done with the first spreadsheet. So we had historical data on units produced and total cost for 16 months. We used that data to estimate a trend line, which was this. Okay, and that was pretty accurate given the R-squared value. And then we just extended this line 2 more months to give us the predicted sales for month 17 is 103,000, whatever the rest of this is. And then the predicted sales for month 18 were about 182,000. Okay. So this is it for example 14.2. We've got 2 more to do, but we're done with this one. Everyone good on this one? Anybody need any steps repeated? All right, so we have 14.2, 14.3, and 14.4 to do today. So we're done with the first one. So whenever you're done with that, or if you're done with it now, you can post that right here. That's not due till next Tuesday, but we're done with this one. Okay, and we can open up the next one, which is the cost regression 2. Okay, so this one's a little bit different, and I guess I don't really need to read. Well, let me see if I can find. All right, so this is now we're gonna have more than one x variable that affects the y variable. So it's the same concept, but now we have multiple products, several products that affect total costs, and we're trying to see together how those different products affect total costs. So suppose the company now produces 3 different products: products A, products B, and product C, and the company's kept track of the number of units produced for each of the product and the total production cost for each of the past 15 months. And the data appear right there. We got that in the spreadsheet. So what we're going to do now is we're going to estimate an equation with multiple regressions. So there's multiple x variables. So what can multiple regression tell us about the relationship between these variables? And how can that be used to predict future values? So let's do this. So it's a little bit different because we're adding, we have more than one x variable, and this is new, but it's just building onto the same techniques we've learned. So let's go to the spreadsheet. Okay, so here's the month, and we got months 1 to 15. All right, so these are the units of each, the units of product A we produced, the units of product B, and the units of product C, and this is the total cost for producing all those goods. And then we think in month 16, we're going to produce this much of A, this much of B, and this much of C. And we think in month 17, we're going to produce this much of A, this much of B, and this much of C. And then based on what's happened here, okay, what do we think the total cost will be based on the total cost relationship in the first 15 months? And we're going to use that to get predictions for month 16 and month 17. Okay, so what we have to estimate now is how total cost is affected by units A, units B, and units C. So we have three, this is like X1, X2, and X3, how all those affect total cost. So we can't just do this with a two-dimensional trend line because we have three different things that affect X. So let me show you what we're going to do here. Sorry, three different things that affect Y. Okay, so we're going to use Excel's data analysis tools, and I'm going to have to show you how to check this or to, activate it if it's not activated, kind of like the solver. So we're going to use data analysis. We're going to estimate a multiple regression now, with total cost is still the Y variable, but we have three X variables, which are units A, units B, and units C. Okay, so if you click on the data tab, what we need to have here, so here's where we had solver, and so we want this data analysis option, and my guess is that a number of you don't have it viewable. All right, so let me show you how to do that, and it's a little bit different for the Mac version, but let's start with Windows. So I'm going to show you now how to activate the data analysis, assuming you have it. Okay, so to do that, File tab, Options, and here where it says Add-ins, click on that. And then down here where it says Manage Excel Add-ins, click on the Go button. Okay, and assuming you're using the student version, or assuming you're not using just the free online version, you will have this option of the analysis tool pack. So see where it says analysis tool pack. If that's not checked, then check it. Okay, analysis tool pack. Check. It should be the first thing because it's in alphabetical order. And then hit OK. And if that worked correctly, when you click on the data tab, you'll see data analysis right here, which is the option we need to use to do the next step. So let's see who do. Okay, so was everyone able to get the data analysis, or who still needs help getting the data analysis option? I know for Mac you have to go, there's a different, like you have to get the drop down like tools, I think. Tools and then add-ins, something like that. Okay, so does anyone not have did everybody got it? All 18 of us? Okay. Okay, so it seems like everyone was able to activate it, but if not, let me know because you can't do the rest of the exercise without it. And if you're using like Google Sheets or like the online only version, it's not going to work. So, all right, seems like okay. So seems like everyone has it. Let's go ahead and use data analysis. Okay, so click on the data tab. All right, and then right above where you used to use Solver, you should see data analysis. Now click on that. Okay, and it should take you to this data analysis tools. And what you want to select is scroll down. And you should see it's in alphabetical order. You want to choose regression. Okay, so choose regression and hit OK. All right, and now all we have to do is input the Y range and input the X range, and then that's it. So where it says, let me see. Okay, so where it says input Y range, hit this button, and the Y range is the total cost range. So include the title and select there E1 to E16. Okay, then hit this, and then the X range, hit this button and choose all of the units produced ranges. So we want B1 to D16, all of this together. All right, B1 to D16. And then you want to check this box that says labels. All right, that's all you have to specify here. And so when you're in this box, Y range is E1 to E16. X range is B1 to D16, and then click on the labels box. And we're about to hit OK. All right, so everybody good? We're ready to do this? Okay. So if you got this, you don't worry about these other things down here. Just specify the Y range, the X range. Oh, how do you get to? Okay, so all right. So let me hit OK, and then I'll go back. So if you hit OK, because I don't think I can get out of this. If you hit OK, it'll give you a separate tab with the results that we'll talk about in a minute. So hit OK, and depending on your default options, it should give you like another sheet with the summary output. So if you got that, we'll come to that in a minute. But let's see. So how do you get to regression? So data tab. Okay, so data tab and then data analysis. And then you should see under the analysis tools, the regression option there. So do you see, Taylor, do you see that? Or can you get to there? Data tools. Okay, so did you select, so what is this? Okay, so close this. So this part, this is, like when you click on it, it doesn't say data analysis. Well, let me see if you selected it. So I don't, are you, let's, so try doing this again, file. And then options. And then add-ins. And then down here where it says manage Excel add-ins, click on the go button. And once you get to the add-ins, you want to choose the analysis tool pack. And so can you get to this option? Okay, so when you get there, click that box and hit OK, and it should give you the proper option. Okay, so now under the data tab, you should see the data analysis option, yeah? Oh, perfect, okay. So now you got it, and you can click on the data analysis and go down and choose regression, okay? And then hit OK. All right, and then this is what you should specify is the Y range. Hit this and choose E1 to E16. And the X range, hit this and choose B1 to D16. And then this box that says labels, make sure that's checked. And then that should catch you up. And then hit OK. Okay, so we got that? Okay, you're welcome. And then, let's see. All right, so I think I did it twice, but. All right, so we should have a separate sheet that has the summary output. So if you did, does anybody not have this? Okay, so let's do this. Okay, so this is the summary output we're about to talk about in a minute. Okay, we'll format it to be consistent. Okay, so we did step one, and now let's go back to the spreadsheet. Okay, and let's format the numbers so it's a little more easy to read. And so if you click on this, like the top left corner, you can select everything. So just hit this button, this arrow up there, like to the top left of the A and the 1 right there. And see how it selects everything, and then you can format everything together. So home tab, and then format cells. And you can just choose number with 2 decimals and the comma separator. And hit OK. Yeah, and that should give you the numbers that are a lot easier to look at. All right, so you get a bunch of stuff. What we're interested in here is this, the adjusted R-square, and the coefficients. And that's it. So the rest of this stuff, you can ignore that for now. We can talk about that or you can learn about the other stuff in a more advanced statistics course. But what you have to be able to interpret or to use is the adjusted R-squared and the coefficients, which we'll talk about in a minute. So does everyone have the same, like, just double check that this is 0.93 and these are the same? Because that's the stuff we need. So is everyone good so far here?
Yes, sir.
Okay. 1% off. All right, so we have a few. So Mason and Trevor, what are the? Do you need me to do the regression again? Or
I'm not sure because for my adjusted R-square it has 0.92, and then for the coefficient standards, I mean it's super close, but it's just not the same.
oh, you just might not. I rounded off the decimals, so that might be the only difference.
Oh, okay.
So yeah, that's fine. It's the same thing probably. It's just maybe you have more than 2 decimals.
Okay.
So it's this
And then
is like yeah.
How do you highlight where you
Oh,
highlight
so
this stuff?
just select it, and then there's a little
Okay.
fill color up here. See that under the home tab?
Yeah.
And then let's see. Oh, Code Mason code. All right. Okay. Yeah. So this, I don't know why it's a little bit off, but it should be about 0.93, and these should be close to that. So yeah, it's okay if it's a little bit off. Okay. So it seems like everyone's on the same page here, and so the next step is to figure out what these numbers mean. And so step 2 is what is your multiple regression equation using the estimated coefficients, and what is the interpretation of the adjusted R-squared and the coefficients for units A, units B, and units C. So how do we interpret these things? And first, how do we just write the equation? So remember before the equation was given to us, or okay, so let me see if I can just write. I'll write the equation based on the coefficients, so hopefully you can see that on the other sheet. All right, so you don't have to do this for this part, but let me show you how to write the full equation based on the coefficients. So here we are. So let me do this. So this is total cost. All right, so if you can see both things at once, this is how you would do. This is how we use these coefficients to write out the equation, and then so this one, this is the intercept. This is the effect of units A on total cost. This is the effect of units B on total cost, and then this is the effect of unit C. Okay, so see how here's the full equation. Total cost is a function of the intercept, 20,261.77 plus the coefficient for units A times units A plus the coefficient for units B, 17.69 times units B, and then plus the coefficient for unit C, 15.23 times unit C. Okay, so that's what the numbers mean. And then you get your estimate by plugging in how many units A and how many units B and how many units C you have, and that gives you the estimate for total cost. So this is how you use these coefficients to get this equation. So you've done it before with just the intercept and 1x. The only difference is we have 2 more x variables. All right, so that is the estimated coefficient, okay? And what's the interpretation of the adjusted R squared? And then the coefficient, so I'll write that here. And so you don't have to do this to turn this part in, but I'll just this is more practice for test exams. All right, so you can see right there, the adjusted R square is 0.93, and this is, last time we talked about the R square, and this one is a little bit, it just makes a small adjustment if you have multiple variables, and that makes it a little more reliable. So just interpret it the same way, but use the adjusted R squared. So again, this is the percent of the explained variation in the Y variable. So you'd interpret this the same way we did in example 14.2. So you would say, okay, on a scale of 0 to 1, it's 0.93, so that's 93%. Okay, something like that. So you got the 0.93, so that's, again, the percent explained variation. So 0.93 means 93% of the variation in total cost is explained by this multiple regression equation. All right, so that's how you interpret that. And then you interpret the coefficients similar to what you do with just the 1x variable, but a little bit different because you just essentially have to hold the other things constant. Okay, so we got, maybe I'll do it over here. All right, let me interpret them right here, because so I can see the coefficients. So let's just interpret these three, okay? Okay, so this coefficient is the effect of units A on Y, which is total cost. So this would mean that if the X variable changes by 1, this is the effect on total cost. So the way you'd interpret this one is if, let's see. All right, so something like that. So this is the individual effect of producing a unit of A on total cost. So the $12.80 is the effect on total cost, and total cost is in dollars. So what this means is each time the company produces 1 unit of product A, total cost increases by about $12.80, the coefficient, on average, and then holding everything else constant because you can only do one thing at a time. All right, so you interpret the other ones the same way, except that's the next one is units B, and the next one is unit C. So okay, so for units B, total cost increases by a little bit more, $17.69. And then for unit C, all right, so you don't have to put that into your spreadsheet. You can if you want, but I do want you to understand what the interpretations mean, because we'll be doing that a lot in the future. So that's what these results, or that's what I want you to learn from the summary output, is how to write the equation, how to interpret the adjusted R square, and then how to interpret the coefficients. Okay, so we're almost done with this one, but questions on the meaning of these results that we just did? All right, so let's finish this one up. Let's see. Okay, let's go back to the spreadsheet. Let's create a new range in column F called estimated TC for estimated total cost. And let's calculate our estimated total cost for each month using the coefficients. And then we'll get the estimates for month 16 and 17. And then we're done with this one. Okay, so I think the best thing to do is let's just copy and paste the coefficients to the other data tab. All right, so if you on your summary output tab, the sheet one, if you select A16 to B20 like this and copy it, Control C. All right, and then let's go back to the data tab and just paste it. I'm just going to paste it here in, we'll do right here. H2, Control V. Okay, Control C is copy and Control V is paste. So we got our coefficients over here just pasted in the data tab. Yeah? Okay, now I think let's make if you make a range name for these, it makes it a little bit easier to read the equation. So if you select H3 to I6 or whatever this range is, and then go to formulas and create from selection, and where it says left column, hit OK. So this will be called intercept. This will be called units A, this will be called units B, and this will be called unit C. And then for our estimated total cost, we can just refer to those range names. So call column F estimated TC. Okay, and the last thing we have to do is get our estimate in the first one, and then we can apply it down the rest of the column. So in F2, let's type in the equation that we talked about. So equals intercept plus units A, or parentheses. All right, units A times the first units A, which is this one, B2, plus another parentheses, units B, times C2, which is the first month one for units B, and then plus the final argument in parentheses is unit C times the first unit C. Okay, so if you got the range names, this is the equation one more time, is equals intercept plus units A times B2 plus units B times C2 plus units C times D2. So all we did was specify the intercept, the three coefficients, and then the actual observations that get multiplied by the coefficients. All right, so, and then, so everybody following along here? All right, so then if you got that, you can just, all you have to do is click on F2, and grab the bottom right corner and drag it down to get all the other observations like this. Okay, so drag it down to F18. And then with that selected, let's just format it to be currency. So Home tab. Format, and then format cells. And then currency. And then you just want the two decimals and the dollar sign.
Sorry, Professor, could you show the different names again?
Sure. These ones? You mean the range names?
Yeah.
Okay, so to do the range names, you just want to select this area and choose, so H3 to I6, and then do formulas. Create from selection, and then left row will give the right name and hit OK. All right, and then if you want to check, you can click on the name manager, and it should show that you got the intercept, units A, units B, units C.
Got it. Thank you a lot.
Okay, and then you put in this equation here. All right, and then apply that down, and then what we're getting to is the goal was to see how much our total cost would be estimated to be in the next 2 months, given we produce this much of unit A, B, and C in month 16, and this many units of A, B, and C in month 17. And the estimated total costs are right here. Okay, so given the analysis, we think that it's going to cost us about 46,000 total to produce all those units for A, B, and C in month 16. And to produce all these units for month 17, this is the estimated total cost, about 45,000. Okay, so this was similar to what we've done before, except we added 2 more x variables, and we want to see how each individual one has a different effect on total cost. Okay. All right, we are done with example 14.3. Everybody good on this one? Any question? Anything need to be repeated? Oh. All right, so that's example 14.3 that goes in here. You can do a separate post, or you can just reply to your previous post. All right, so we got one more to do, which is example 14.4. Okay, so you can open up in the same Blackboard section, open up cost regression 3. Okay, so this one we have here's the months and here's the total cost. The difference here is we produce at different plants. So there's different locations, different plant locations that we produce this product, and the cost is going to be dependent. Like the cost is going to go up or down, given which plant we produce at. So we're trying to see which plants cost what, and if there's a difference between producing at plant 1, plant 2, and plant 3. So that's the goal here. Okay, so suppose the company now produces a single product at 3 different plants, 3 different manufacturing plants. As in that example, the company wants to regress total cost on units produced, but it suspects that the relationship between these variables might differ across plants. So it has monthly data from the 16 months for each plant, and which is produced at each of the plants 1, 2, and 3. All right, so let's look at these. And let's create binary or dummy variables for the different plants and see how the total cost varies from plant to plant. Okay. Now let's do example 14.4, last one for today. Let's estimating production costs at 3 different company plants. So cost regression 3. And the first thing we're going to do is add 3 new ranges in columns F through G, E through G, called plant 1, plant 2, and plant 3. Okay, and well, let's do that first. Okay, so step 1 is we got, here's the month, here's the plants, here's the units produced, and here's the total cost. Right here in E1, let's call this plant 1. Let's call F plant 2. And let's call E plant 3. Okay, so let's use the equation that's given in step 1, and then we'll modify it for plants 2 and 3. Okay, so here's your equation. Let's put that in cell E2. So right here, the equation is equals if okay, so equals if in the parentheses, if B2 equals 1, comma 1, comma 0, and then close the parentheses. So what this tells you is that if the plant in this row is a 1, then put a 1 there to be at plant 1. Otherwise, put a 0. Okay? Okay, so if equals if B2 equals 1, comma 1, comma 0. So it's a simple if argument saying that if this is a 1, which it is, put a 1. If it's not, put a 0. It's some other plant. So that's your equation. Enter. Okay, so let's write the same equation for plant 2 and plant 3, but let's say this is for plant 2 and this is for plant 3. So basically, these variables are going to be 1 or 0. 1 if it's at the current plant, and 0 if it's not. So in F2, the equation is equals okay, if B2 equals 2, comma 1, comma 0. So now if it's a plant 2, give us a 1. If it's not, put a 0. So if b2 equals 2, comma 1, comma 0, and then close the parenthesis there. And we got to do one more for plant 3, and then we can just apply these equations down for the rest of the data. So in G2 equals okay, if in the parentheses b2 equals 3 this time for plant 3, comma 1, comma 0. So if it's a 3, put a 1 for this this cell. If it's not, put a 0. Okay, so we got this one for plant 1, this one for plant 2, and this one for plant 3, and then it's going to recognize if we're at that plant, it's going to automatically put a 1 in the cell. And if we're not, it's going to put a 0. So there's always going to be a 1 and then 2 zeros that denote which plant we're at. Okay. So if you got those 3 equations, then select them all at once. Select E2 to G2 like this. And then we're going to just grab the bottom right corner and apply it down for all the other ones like this. Okay, so if that worked, you should have a bunch of 1s and a bunch of 0s. And you should note that you should just go through and see, like, if we're at plant 1, there's going to be 1 in the plant 1 column. And if we're at plant 2, there's going to be 1 in the plant 2 column. And if we're at plant 3, there's going to be 1 here. And otherwise, so you should have in all the rows 2 zeros and a 1 that denote exactly which plant the observation came from. All right, so did we get that part? Okay, seems like we got this, and then we're going to estimate. We're going to use data analysis again in a minute, but first I think it's so step 2. Let's use data analysis and let's estimate a regression where total cost is the y variable again, but we have independent variables, units produced, and then plant 2 and plant 3. Now the reason we only have plant 2 and plant 3 is because when you specify something with binary variables, you need to only use 1 less than what you actually have, because basically what we're saying is that when this is 0, and this is 0, then we're automatically at plant 1, and we don't want to double count, so you need to specify 1 less, because plant 1 is by default the case when plant 2 and plant 3 are both 0, that's plant 1. So you don't need to include plant 1 because plant 1 is identified as when plant 2 and plant 3 are both 0, and that way it doesn't run into problems, it doesn't double count. Okay, so let's what I want to do here is just make it a little bit easier to select it when we do the data analysis. Let's do a little copy and pasting. If you want to select the total cost column, right? So select D1 to D49 and then copy it, Control C. And let's just go over here to I1 and paste it, Control V. And then let's put the units produced range right next to it. All right, so select C1 to C49 and copy it, Control C. And let's paste that right here in J1, Control V. And then I want to paste plant 2 and plant 3, but I don't want to paste the formulas, I only want to paste the values. So if you select F1 to G49 and copy it, Control C. And then go right here to K1, and instead of just hitting the default, go up here. Under the Home tab, you should see this Paste drop-down menu, and click on that. And choose the option that just says Values for that. Okay, so in the I column, we have total cost. In the J column, we have units produced. Here we have plant 2, but they're only values, see? And then the L column, we have plant 3. All right, and then we have all the things we need for the multiple regression right here.
Hi, Professor.
Yes.
When I copy the plant 2 and plant C, and it also copied the form, but it didn't copy the number, so I got 0 all of them.
Okay, so let's do that again. So we need to do. Okay, so first just copy the plant 2 and plant 3 like this. Let's recopy it to Control C. So you want to copy F1 to G49, and then go here in K1, but don't hit the shortcut. Home tab, and you should see this paste drop-down menu. And you want to choose the option that says values.
Yeah.
And that should paste only the values. Did that work?
Yeah, got it. Thank you a lot.
Okay. Okay, so everybody good? We got the total cost, units produced, plant 2 and plant 3, but make sure that the plant 2 and plant 3, they're just the numbers, not the equations. All right, so step 2 is let's go hit Data tab. And then hit Data Analysis. Okay, and you want to do the same thing, regression. Make sure that's selected and hit OK. All right, the Y range, let's reselect that, hit this button. Y range is total cost, which is I1 to I49. All right, X range, let's reselect that, hit this button. And the X range is select all this together. J1 to J49. Okay, and then make sure this box is checked. So double check everything else you can leave the same. Y range is I1 to I49. X range is J1 to L49, and then make sure this box is checked for labels. And then let's hit OK. Okay, and hopefully we got a separate tab that has the summary output again. All right, so did everybody get the summary output here for this example? All right, so the last step is just to explain the results. So step 3 is what is the multiple regression equation using the coefficients here, and then what's the adjusted R squared, and then what do the coefficients mean? So let's format it to make it a little more seeable, make that viewable. Okay, so if you hit this, that little arrow at the top left of the A and the 1, and just format the whole sheet 1 summary output tab to like this, home tab. Home tab format, then format cells, and then just change it again to number with 2 decimals and the comma. So we're just formatting here so you can see the numbers a little more clear. All right, so again, the things that we need to focus on are the adjusted R squared, and the coefficients. Okay, so everybody has values similar to these ones. So the adjusted R squared is about 0.99, and then these should be your coefficients that you got for the intercept units produced in plants 2 and plants 3. Yeah? All right, so let's interpret the adjusted R squared, then we'll write the equation, and then we'll interpret the coefficients. So here's, actually all right, so I'll do it right here. Okay, the equation that these coefficients specify is this. All right, so here's the equation based on the coefficients. Total cost is a function of the intercept, which is 22, 851.94, plus the coefficient for units produced, which is 204.15 times units produced, plus the coefficient for plant 2, which is 12,971.97 times plant 2 minus, all right, this is a negative coefficient, 15,045.29 times plant 3. All right, so there you go. That's the equation. Then this is the adjusted R squared. It's just the percent of the explained variation in total cost. So you can just say that All right, so 99% of the variation in total cost is explained, given the coefficient on a scale of, it's almost 100%. Okay, and then last thing is let's just interpret what the coefficients mean, and then we're done. Okay, so this is how much it costs to produce a unit on average. So units produced are just the average, the total cost of one unit, right? So if units produced increases by one, this is the effect on total cost. And that's the same as saying, this is how much it costs to produce a unit. Okay, so it costs $204.15 to produce one unit on average, holding everything else constant. So that's the effect of units produced on total cost. Okay, and then these are the binary variables. So this is how much more total cost is compared to the one that was emitted, which is plant one. So this is the additional cost to produce at plant two compared to plant one. So you would say, okay. So total cost is $12,971.97 higher at plant two compared to plant one. And then again, on average, holding everything else constant. So this is the added cost of producing at plant two compared to plant one. Now you can see that plant three is this much less compared to plant one. So basically, plant three is the cheapest, plant one is in the middle, and then plant two is the most expensive that we got from our data. Okay, so you can interpret plant three as like this. Okay, so total cost is $15,045.29 lower. All right, see the minus sign lower at plant three compared to plant one. And then again, the caveat on average, holding everything else constant because you're isolating the effect. Okay, so these binary variables, the coefficients are just, if we're at plant two, if the observation is a one, then on average total cost is this much higher. And then if we're at plant three, on average total cost is this much lower. And again, compared to plant 1 because if this is 0 and this is 0, then we're defaulted at plant 1. So these are in comparison to the omitted plant 1. All right, so I think we've went over time a little bit, so we're done with this one. So you can save the cost regression 3, and we've completed all of them. So all of those. So I had some practice questions, but we'll do those next time because we're out of time. So you can look at these if you want, but we'll get to those later. But the completed cost regression 1, 2, and 3. Okay, go there, which looks like some of you already done. So we're done with today's exercises. And next, so if you haven't done if you haven't submitted your midterm 2 via email, then please do that by the end of today. So that's the first thing. And then these are due next Tuesday. And we'll do some more examples in chapter 14 on Thursday. Okay, so sorry we went a few minutes over, but I think that's it for today. And thanks everyone for joining, and I'll see everyone Thursday morning.
Professor,
Yeah, yes.
on my regression analysis for plant 3, I got 0 coefficient. Or let me phrase that, all the coefficients are wrong for that one.
Okay, so I can, if you want to post it, I can look at it right now if you have a few minutes.
Okay, let me do that right now then.
So post it to here. Okay, is this Dominic?
Mm-hmm.
Yeah.
Let me just do that. Hopefully my computer puts the right one. It should be posted now.
Okay, let's see.
Sounds that should be. Right.
I think you posted just the blank one again.
Yeah, my computer sometimes takes a while to save a file.